Today we go look simple trigonometry ratios. Simple trigonometry ratios. Now, what we go fit use to solve problems, to get the angles of right angle triangle, and also we can use them to solve to get the side of the right angle triangle. We will look 3 of them for now. What we go fit use to take solve problems to get the length of right angle triangle and to get also the angles inside the right angle triangle. First, before we look at them, we go define the right angle triangle. We say right angle triangle na triangle where one of the angle na 90 degree, and we dey use this box to represent the 90 degree. Now the side when they face this 90 degree, we dey call am hypotenuse. We call am hypotenuse side. While the other 2 sides of this right angle triangle, we dey either call them opposite side or we dey call them adjacent side. Now we say that the hypotenuse side na the side when they face the 90 degree, e dey constant. But the adjacent side and the opposite side for a right angle triangle, e dey change depending on which angle we dey look. Now the angle we dey look, now we take dey determine which side go be the opposite side and which side go be the adjacent side. Now make we look this triangle for example now. Make I put angle here. Say this angle na theta. Then I want to call this angle here to be beta, or let me use this angle here na theta. Then this one here na alpha. Now we get 90 degree. The side wey face 90 degree na hypotenuse. Then we get theta here and we get alpha here. So if we want to redraw this triangle now, for us to know which side be the opposite, we will not consider which angle we dey talk about. So when we want to consider theta, if we want to consider this angle theta now, I go redraw this now. This side now, we go call am opposite, because na im dey opposite to the theta. And why this side still remain hypotenuse? The hypotenuse side no dey change. It must always be the side where they face the 90 degree, where they opposite to the 90 degree. And because this side now opposite, this side now will become adjacent. So the adjacent, and when they adjacent to the angle we dey consider, while the opposite side na the side when they opposite to the angle when we dey consider. So for this triangle now, make I call this one A, B, and C. So look at this triangle now. A, B, and C. When we dey consider theta, then A, C na opposite, while B, C na adjacent to theta. But if we want to consider alpha, I will draw this again. This side na still hypotenuse. This na alpha now. Under alpha, here go come become opposite. And here become adjacent. So we now know say the adjacent and the opposite side e dey change depending on which angle we dey consider. We get three simple trig ratio wey we go learn today. The first one we dey call am sine of angle. The second one is we dey call am cosine of angle. And the third one we dey call am tangent of angle. Wetin we say this sine be? All of them, all these trigonometry ratios, wetin we say these trigonometry ratios be? We dey use them to solve problem for right angle triangle. We take and take dey calculate the length of the triangle and also to calculate the angle inside the triangle. Our Pythagoras na only the length of the right angle triangle you go fit calculate. You no go fit calculate angle. So now we dey look this other formula now, or this other ratio now. We go fit calculate both the length of the triangle and it go also fit calculate the value of the angles inside the triangle. Sine of angle. Wetin be sine of angle? Sine of angle, we say na the ratio of the opposite side to the hypotenuse side of that angle. Sine of angle. We say sine of angle. Sine of what? Angle is equal to what? Opposite over hypotenuse. When we say ratio, it means divide, to divide like this. So when we say the ratio of opposite to hypotenuse means the opposite side divided by the hypotenuse side. Now I'm going to give you the sine of the angle. This sine of angle, we write am now as sin, sine. Now let me use an angle, let's say theta. So sine theta, we can say it's opposite over hypotenuse. So the short form is sin to represent sine. We use this theta here to stand for the angle. This is now sine of angle. When we look cosine of angle, cosine of angle. What in cosine of angle be? Now, ratio of the adjacent side divided by the what? Hypotenuse. So our cosine of angle is equal to the what? Adjacent of divided by the hypotenuse. So you see now say cosine na adjacent, and we dey use short form cos. So anytime you see cos means cosine. We can use cos theta. Theta here stands for the angle when we dey talk angle. We say it's adjacent. Now adjacent over what? Divided by hypotenuse. That's how we get cosine of angle. Look at tangent of angle. Tangent of what? Angle. What is the tangent of angle? Tangent of angle, now when you divide opposite divided by the adjacent. So it's opposite divided by adjacent, it will give you what? Tangent of angle. Tangent of angle, we normally dey short am, they call am tan. So tan here theta is the angle opposite over adjacent. Tan theta is equal to opposite over adjacent. This now be the three basic trigonometry ratio what we go use to solve problem to find the side of a right angle triangle and also to find the angle in a right angle triangle. Now we will look at some questions. Question 1. Look at this question now. Question 1. For example, say given triangle ABC with side AB equal to 4cm, side AC equal to 5cm, and angle ABC equal to 90 degrees. They say find A side BC, find ACB, which is to find angle C, and find BAC to find angle A. Now, make we look at this question. When they give you question like this, when you see this line AB, capital letter, the capital letter they stand for AB with a stroke like this. They stand for the side AB. Capital letter AC with stroke like so. They stand for the side AC. And they give you this as angle. This means angle ABC. They tell you say the letter wey dey for center B is equal to 90 degrees. So make we draw this triangle. Make we see from this. Look at the triangle now. This triangle they tell you say the 90 degree here now here big day. Then this now our A and this now our C. Hope you see that now our AC, let's say here now 5cm, and our AB here now 4cm. Now they want make we find BC, this length of BC. And they also want us to find this angle here. Namely, our ACB, to find this angle C here. And waiting to be the angle for A here. Namely, our BAC. Make we find out. We fit use Pythagoras to find this side. But we no go fit use Pythagoras to find the angles that were there inside. But we also fit use this our trig ratio. Also, we fit take and take find this side if we know this angle here. But let's use Pythagoras. This now what? BC. When we square them plus 4 square, it will give us equal to what? 5 square. So what we will get now be this. Our BC square plus what? 4 square now waiting 16. 5 square now 25. This 16 when it cross the equality sign, it will become minus. So our BC square, it will become 25 minus 16. 25 minus 16 will give us 9. How we go take get our BC now? We go find the square root of 9. So our BC will become square root of 9. Will give us 3cm. Now we don't know say our BC na 3cm. BC is equal to 3cm. Now we will go to the next question. ACB. We want to look for the angle of C here. How we go take look for the angle of C here? We use any of the trig ratio. Now make we use that of sine. Now this is the triangle what we get now. We get 3 cm, we get 4 cm, and we get 5 cm. We want to find this angle here. We fit say sine C, which is this angle here now, is equal to what? Opposite over hypotenuse. What will be the opposite of C here? Now 4. And what will be the hypotenuse for C here? Now 5. So our sine C is equal to 4 divided by 5. 4 divided by 5 will give us 0.8. How would they get that value? How would they get 0.8? Make I explain them for you. 4 divided by 5. 5 big past 4. So you know go fit divide. We will go put 0 here. Point. We go bring down this 4 and add 0 to that. So it become 40. 5 divide 40 will give us 8. 8 times 5, 40. So how would they get 0.8? So we don't get 0.8 now. What do we go do now to get the value of our C, the angle of our C? We go to our 4-figure table. Under sign of angle, find the angle will give us 0.8. So when we look for the value from the 4-figure table, the angle will give us 0.8 now 54 degrees. As far we don't get this angle, to get the third angle A now, they easy. Look at that. Make I draw the triangle again so that we go understand what we do. Now we don't say here now 54 degrees. Here now 3 cm, 5 cm, and 4 cm. Here now A and here now B. Look how the triangle now be now. A, B, C. Now from this triangle A, B, C now, we don't get this angle C to be 54. How we go take get this angle A? It's just for us to subtract 54 from 90 degrees. So we now say our A plus 54 equal to 90 degrees. Our A will now be 90 minus 54, and A is 36 degrees. Why would they subtract 54 from 90? Because now right angle triangle, this angle here now 90 degree already. And if we add all the sum of the angles together, it's supposed to give us 180. We don't already get 90 for here. So it remains 90 to complete these two before. So since this now 54, the remaining one will complete 90 for us. Now see the same thing as if we say A plus 90 plus 54 is equal to 180 degrees. Now the same thing it will give you. What it will give you if you add this and this together, it will give you 144. So your A becomes 180 minus 144. A will still be what? 36 degrees. So this one they short to use. No say immediately you get one value of the right angle triangle, the angle, subtract that value from 90, it will give you the next one. Question 2. Find the length of the letters in the triangle given below. And we are given triangle. We have the triangle X, Y, 60 degrees and 1. 60 degrees and 1. Let's look at that. From this triangle, this angle here, since here is 60, automatically this angle here will give us what? 30 degrees. Solution. Now make we look the solution. I say because this triangle here is, the angle here is 60, this is right angle triangle, automatically here becomes what? 30 degree. How do we get that? If for example I want to name here A, B and C, I want to name them A, B and C. This angle here, our 60 degree plus what? This angle A here will be equal to what? 90 degree. And A will be equal to 90 minus 60, which gives us what? 30 degree. So we will get 30 degrees there. Automatically, we now know that. We want to look for the value of y and x. So we will go back to our trig ratio again. We know this angle to be 60. We don't know this. We know this one to be 1 here. How we fit relate them? We can also relate even with this 30 and this one. I want to consider angle 30. Let me consider angle 30 now, what we don't get for here. From this value, angle 30. If this now angle 30, I'm considering angle 30 now. Here now 1, and here now x, and here now y. It means this side will be opposite for angle 30, and this side will be what? Hypotenuse. So if we go to our sine 30, what will be sine? Sine are opposite over, look at it, opposite over what? Hypotenuse. What will be the opposite to 30? Now 1 all over. What will be the hypotenuse? The hypotenuse here now x. So write x. So it means, say now, sine 30 is equal to 1 all over x. If we go for our 4-figure table, look for the value of sine 30. Sine 30 now 0.5. So we'll find that value now, 0.5. So what do we get now? Now, 1 over x is equal to 0.5. We want to find the value of x. We want to find the value of x. How we going to get value of x here now? If we invert, turn it upside down now, we will get x over 1 is equal to 1 over 0.5. What is the 1 over 0.5? If we divide that, it will give us what? 2. So x is equal to what? 2 cm. 1 divided by half will give us what? 2. And also some persons go nothing understand this. Let us do this division here so that we feel understand that. Now look at 1, 0.5. First, 0.5. If we want to pull this 0 from here, if we move the 0 once, we go add 0 for up. It will become what? 10 divided by 5. And 10 divided by 5 will give you 2. Simple. That's how we get this one now. So our x now 2 cm. As we don't get the value of our x now, the triangle now, it be like this now. Look at it. Now be 2, 1. This is 30. This is y here, and this is 60. Now what do we get now? So we want to look for that value, y value now. If we want to find y value, again, this is Opposite over what? Hypotenuse. We can also have 30 here. To this one, now adjacent. Now let's go. Opposite over hypotenuse. Sine 60 is equal to opposite. What is the opposite of sine this 60 here? Now y be the opposite. And the hypotenuse, now 2 be the hypotenuse. So we now get sine 60 is equal to y over 2. How we will get our y now? Cross multiply. Y is equal to 2 sine 60. What will be sine 60? Sine 60, if we look out for 4-figure table, sine 60 now 0.866. 0.866. So our y will now be what? Multiply now. 2 times 6 will give us 12. 2 carry 1. 2 times 6, 12 plus 1, 13. 3 carry 1. 2 times 8, 16 plus 1, 17. So our decimal place 1, 2, 3. This is cm. So the value of our y is 1.732 centimeter.